Okay, the other day I had a student ask me about calculating the R value for a wall in Revit. And I know that in Revit, they actually set up information for the thermal conductivity and density of a wall. Never really paid a whole lot of attention to it before, but when I actually started to set up a calculation and look at the R value, if I go ahead and select a wall, and this is a wall the student built. This wall is actually a 7-inch wall complete. But there's siding on it, there's plywood, there's a vapor retarder, there's a membrane, and then of course drywall or gypsum wallboard. But the main insulating factor for the wall is a batt insulation layer that's a standard to Revit. So this is that structure wood joist rafter layer that's batt insulation. When I go to the thermal information on that particular material, it says that the thermal conductivity is 0.0110, and the rest of the information here is specific heat and density. Looking at that, I then headed back out of the information here and come up with that there's a thermal resistance or an R value of that wall of 41.14. Thinking that through, that this is a 5.5-inch stud cavity with batt insulation, there's no way that that can occur when R19 insulation is fairly standard for a 5.5-inch cavity in a wall. So I started hunting around online for information and found some information here on this website. This is electronicscooling.com and thermal properties of building materials. And what I found was that fiberglass has a thermal conductivity, and this is of course in Kelvin, of 0.04. So I had to then calculate that to found a converter to calculate that over to BTU for thermal conductivity. So what I did is I then found a calculator, this online calculator, and started converting this information over to see how I could then set the wall up to respond in a way that was seeming to be a little more realistic to what batt insulation layers would give. So then went ahead and set that up. Looking at this, in fact, what I'll do is to eliminate the idea of siding or wallboard or any other insulating factors to this, I'm going to go ahead and just create a brand new wall. So I'm going to go to my level 1 and grab my wall tool, and I'm just going to go ahead and create a new wall. Hit edit, I'm going to hit duplicate, and I'm just going to call this, actually I'm not even going to duplicate that wall. Instead of doing this, I'm going to go in and I'm going to grab a new wall. And I'll grab the standard 8-inch or grab a 6-inch is fine, and then hit edit. Then I'm going to duplicate because I don't want anything in this. I'm just going to do R value test because I just want to see how I can test this out. So I'm going to go into structure and I'll set this up to be 5.5 inches, and then I want to actually go in and find that this batt insulation layer. Now, I don't want to mess up the information here that's set up in Revit, so I'm just going to select it, right-click, and duplicate so that I'm actually changing a different layer. I'm going to be changing this new layer. This is batt insulation, and I'll go ahead and rename this. The end of this, so I can see this is going to be R value test. Never done this before, but we're going to find out how we can calculate this a little differently. So going into thermal, I'm going to go ahead and start putting in the rest of the information here that would be accurate to the thermal properties for fiberglass coming from this material thermal properties table at room temperature. So what I first need to do is come up with thermal conductivity. So I'm going to find the thermal conductivity portion here, so specific heat, thermal conductivity. And I want to set this up so that this is going to be the same. This is watt meter Kelvin, and that's what this is, and that's going to be 0.04. So I'm going to set this up to be 0.04, and I'm going to what's going to be BTU. So I'm going to come over here and find BTU, and that's going to be foot. Let's see here, BTU foot. Yep, that's it, IT. So there is the conversion for 0.4 watt meter Kelvin, and I'm going to then put that information here. So just go ahead and copy that number, copy, and go back over here to Revit and drop that into that position for thermal conductivity. Now, I could then go through specific heat and density if I would like to do that. fairly simple to do as well. Go back into the thermal properties. There's specific heat. Come down for fiberglass. It's going to be 700, and that's going to be in joules Kelvin. So let's do specific heat capacity, and that's in joules kilogram Kelvin, and we're going to go ahead and make that 700. And then we're going to come over on this side and find specific heat. Again, we need to look for BTU pounds. Let's see here, BTU pound, IT pound Fahrenheit. All right, so there's my specific heat. I'll go ahead and copy that and go ahead and drop that into the wall. And the last thing I can look for is density. And I'm going to go back out to density, which it's given here as well as 150 kilogram meter squared. So then I'm going to go over here and I'm going to find density. There it is. And now I'm looking for kilogram meter squared. That's going to be, was it 700? No, I'm sorry, 150. Set this up to be 150. And then come over on this side and see this is in pounds per cubic foot. So we're going to slide down here to pounds per cubic foot. There we go. So there's my specific there's my density, so I can go ahead and highlight that information, copy that, and go ahead and drop it in here. Paste. All right, so let's see what happens here. I'm going to hit apply, hit OK. And at 5.5 inches, I should be able to see something in around 19, well, there's 19.83, which seems far closer to getting an R value of 19 in a 2x6 stud wall. With bad insulation. So hopefully this is going to walk through quick understanding of how this works out. I am not an expert by any means, but from my building experience and drawing experience, this seems far more reasonable than the original estimate Revit was putting out.